Hi, I'm Colin. I'm here today to present on Chrome extensions. By the way, if you have any questions at all at any point during the talk, feel free just to drop it in the track 2 channel. So let me preface this with why I first started actually taking a look at Chrome extensions and some of the motive behind the research that led to this presentation. In August, Google announced it was starting a new bug bounty program. One of those items that they were putting a bounty on was Chrome extensions along with apps. Kind of a breakdown of what this talk will look like is first I'm going to talk about that bounty program, my initial process of collecting data. From there, I'm going to go through a quick crash course on how to take apart Chrome extensions, kind of figure out what's going on, take a look at communications, and get an idea of what is actually happening behind the hood of a Chrome extension in a couple different ways. From there, I'm going to be talking about the actual results of my research, which is actually threat hunting to find Chrome extensions that are either abusing user data privacy or delivering adware or other things like that. I'm going to be talking primarily about one family of Chrome extension called Linker. If you don't know what that is, don't worry, it's not super common, or at least not well known. So I'll be going into that, a couple other examples, and then finally I'm going to be talking about how I actually went about disclosing this and what kind of benefits that had to me, specifically bug bounty rewards and stuff. And then we'll have Q&A. But feel free to drop any questions if you have any come up. A little bit about myself. I just recently graduated from Purdue with a degree in cybersecurity, one of the first to be in like the cyber on the actual degree. So that was certainly interesting, kind of the guinea pig class, but it was a good experience overall. I just started, actually this was my first week at Sophos as a threat analyst on their managed threat response team, and you can find me on Twitter. So background information, I kind of started going into this, but Google created this rewards program called the Developer Data Protections Reward Program. And essentially there's three different avenues that you can go about it. A, you can look at applications in the Google Play Store. So any application with over 1 million installs is actually in scope for the bug bounty program. The other thing would be their API. So things, if previously known as the Chrome Web Store applications, you could like install them and they would be like Google Docs, but I think third party or something like that, have now moved to the G Suite applications. Those use the Google API. And if you can find signs of data abuse or someone abusing that API of a G Suite application of over 50,000 users, you can potentially get a reward there. And finally, the one that stood out to me was Chrome extensions. Any Chrome extension with over 50,000 users is in scope to receive a bug bounty from Google if you can prove undeniably that that extension lacks transparency in how it handles its user data, as well, or if it's violating the Chrome Store minimum user data privacy requirements. So when Google first announced this last August, I knew I wanted to look at Chrome extensions. I'd done a little bit of stuff with web, but I didn't really know where to start. But I knew I wanted to download a good bit of Chrome extensions and get an understanding of what's actually normal in this environment. So I started developing my own tooling in Python, ended up downloading around like 1,000 extensions that were within scope of the bounty program, stored them offline, and then did some just extracting some more information from them to create a CSV file with information on what extensions have which files and where do those files actually call out to, aka what URLs are there. From there, I knew I wanted to take that and somehow turn it into a bounty reward, but at first I wasn't really sure where I was going to go. However, I started development anyways. So I developed this tool called Chrome Hunt, and it's built in Python 3. And it pretty much just goes through the Chrome Web Store and downloads different extensions. I have it parsing for extensions that, of course, are in scope, saves it offline. After I developed it, I learned that there's actually a better way to do this, which would be to look at the sitemap of the Chrome Web Store. From there, you can use a script to just crawl that and download the entire store much faster than in Python. There's actually a speaker, Dylan Katz, he's speaking on Saturday at 11 a.m., who published a tool, which is this link on the bottom of a script that can actually download and clone the entire Chrome Web Store much faster than I was able to do in Python. But nonetheless, I wanted to do this partially just to gain the experience and because I like development in Python. So one of the most prominent tools when it comes to actually analyzing Chrome extensions and looking into security of Chrome extensions is CircleCityCon. I don't know if that's necessarily how you pronounce it, but a tool by DuoSec that clones the Chrome Web Store every 3 hours and develops risk rankings on Chrome extensions based on its different policies as well as URLs and a few other things. If you have the ID of an extension, which you can find in the Chrome Web Store URL, you can submit it to this website application and it'll give you a report, allow you to view the source code. But one of the things that I think is the most useful is the entry points feature, which is shown on the right side of the screen. From the actual report of the extension, you can have it actually parse entry points, and then from there, it will actually break down and give you snippets of code that it thinks could potentially be dangerous. So sometimes this can be just an easy, quick way. If, you're on someone else's computer or you don't have access to offline tools, you just want to go to a website, click submit, take a look, and you can see the permissions and some of the basics. However, if you want to go in more depth, the tool that I like to use is called ext analysis, which also works for Firefox extensions, not just Chrome extensions. But like CircleCityCon, you can submit different extensions. It will store it offline, run some analysis, and give you information. I find that ext analysis just has a lot more information available. It has source code viewers that have automatic beautifiers and can kind of clean up the JavaScript. It has direct links to search things on VirusTotal from the domain and URL that it finds. And one feature that I think is really cool is it uses Neo4j to plot the files and actually allow you to gain like a visual look at what the source code of that extension looks like. Although ext analysis is good, oftentimes it's not better than actually using the built-in browser tools. So you may have used inspect element as a joke or something like that, or perhaps as part of your day-to-day job, you use it a lot. I don't know. But for Chrome extensions, you can actually access the runtime environment of that extension installed in your browser and then do further testing with these developer tools. To do that, you visit Chrome, this website address here, enable developer mode, and then from there you can see all your different extensions will have this new line that says inspect views, and if you click on background.html, it'll take you directly to a new window of the runtime instance for that Chrome extension. From there, you can actually interact with the JavaScript variables. You can take a look at what's being actively stored and going through memory of that extension, as well as you can go to network and then you can enable it to log and store different network requests and even start to kind of man in the middle some of the traffic between the extension and be able to filter better to exactly what is coming from this extension. So these tools are good, and if you just are a user of Chrome extensions and you're curious what's actually happening, then these tools might do the job. Now, when you have an entire clone of 1,000 extensions or 5,000 extensions or something like that, and you want it to be able to do analysis on all of them, it's going to take a lot longer, which is why I started researching into how to automate that with Python. And because I enjoy Python, kind of a reoccurring theme here. However, so the code you see here is a simple snippet of what it takes to load up a Chrome extension in Python with the Chrome Selenium WebDriver. So this will create a new Chrome window, install the Chrome extension from disk, set it up to use your proxy. So you can run any kind of proxy on your own side, whether that's burp. I like to use man in the middle proxy. And then from there, actually start to intercept all traffic from the browser. So not just the traffic from the Chrome extension, but everything from that new browser instance. And then now you can start to do a little bit more with dynamic analysis and building off of it. Since it is in Python, you can really do a lot with some simple automation. So after spending a few months in the fall of my last school semester, kind of working on this project on the side, developing when I can, trying to figure out why my spider kept crashing and having issues with regex URL parsing, you know, the fun things you expect in your side projects, I decided that it was time to get more focused, get more precise, and target specific families of adware and malware that had been found in the Chrome extension store before. So like what as needed, I did my background research, and first I found this article by AdGuard about Unimania. Essentially, it was some fake ad blockers. They had video downloaders, you know, PDF mergers, the kind of utilities that people actually use in the Chrome store. And when you installed it, it would immediately grab your information and then register you within their command and control server, and then ultimately start to scrape some of your social media information, posts you visit, websites you visit. But I was able to find a Chrome extension being operated by the same group that was actually live in the Chrome store called Video Downloader with over 1 million users. So I looked at the URLs that I had parsed out from my Python script, and I saw a couple different ones that referenced weird looking addresses, took a look into it and found this extension, and ultimately was able to correlate it back to some of the other research posted by AdGuard. Now, what does this actually look like in terms of communication? When you install this video downloader, the first thing it does is it reaches out to this strange looking S3 bucket, which for the record is the exact same S3 bucket that was included in the report by AdGuard in 2018. So I guess, you know, not much concern for having to change operational security and tooling and infrastructure. You can see they have my device that I was using, my user agent string, a unique seed, and just a couple of strings that's like device install. Nothing too bad at first. However, it gets worse. This extension actually had custom different libraries for social media that would inject scripts into your browser and then collect information about what extensions or what tweets you view, promoted tweet information, user account information. So you can see on the right here, it's collecting the unique IDs of tweets, and you can see that there's another variable here referencing the Chrome extension itself. This was taken in developer tools of Chrome, by the way. On the left here, there's a different domain that it communicates, fbdownloader.net/filter/adult. And within the actual form data, it will collect the URL that you are visiting for every page you visit, as well as your unique GUID ID for the installation of that browser. Not great stuff. However, most of my research has been focused on the linker family of malware. What is linker? Linker is I said in my overview that it was a persistent threat that wasn't very advanced, but in reality, they are somewhat advanced in the sense they've been around for almost over 7 years now, and they managed to have massive campaigns, ton of infections. I guarantee you they're making good money, but you'll see why I say they're not necessarily the most advanced later on. But how they actually make profit and what they actually do is redirecting user traffic and performing different sort of cookie stuffing. So when you visit something like Amazon or another website that has affiliates and promotions, it will inject stuff into your browser to make sure they make some money for quote unquote referring you to the site. But they've also been seen to deliver other adware such as coin miners. However, Chrome already uses enough RAM. You add coin miners to every site you visit and things can get pretty slow pretty quickly. So I don't think that worked out well for them. This research also really, really helpful. And honestly, without other researchers sharing information like this and giving open public reports with indicators of compromise, this entire project I did and research I did probably would not have been possible. So from the report from Security Street, the company that shared a lot of indicators of compromise of a linker campaign in early 2019, I was able to actually threat hunt and find more infrastructure being used for these campaigns. There was a handful of ways that I was able to pivot between pieces of information and find out more about this threat actor and their Chrome extensions. I'm sure that there's even more ways to do it from what's listed on this page, but particularly what really helped was DNS and overlapping just infrastructure of using the same servers for different websites and applications. But there were other aspects to it, like looking at the code offline and using some signatures there, which I'll go into. So for those who haven't heard of urlscan.io, it's basically like VirusTotal or one of those other online analysis platforms, but for URLs. I really like it. It has a great search feature, which I was able to use to hunt on one of the IP addresses that was originally disclosed in previous linker Chrome extension reports. You may see this part here that says end LT equals. That's actually a parameter that's used by the linker adware to communicate with its command and control servers. So one thing you may notice right away is these heartbeats. Essentially, these extensions that they use and the linker adware will use will heartbeat and just kind of beacon to a server until it receives a configuration that has a second stage of JavaScript. Unfortunately, through most of my research, I haven't been able to see their second stage of JavaScript that much because they do really good environment checking. But you can actually see some of these second stages in previous data, including stuff that has been on urlscan.io. For an example, we can look at this IP address and this specific report of a URL hosted on that IP to a domain called what'schrome.org. I actually was able to pivot from this and find a Chrome extension that was like a WhatsApp login. It's like WhatsApp for desktop, totally legit. It may have been at one point, but it was delivering adware and being used as a mechanism for redirecting traffic and other malicious activity. So in this specific request, this might look like gibberish, but this right here is actually the ID of a Chrome extension. So on the web store, every single Chrome extension has a unique ID that is just different lowercase characters, no numbers. I think it's 32 characters. And the linker Chrome extension will actually broadcast their ID in the web request, which made it easy to actually go from a threat feed to figuring out what extensions are they talking about. In this case, quick search for this, and you will find third-party Chrome extension web stores talking about what's green 4.6. Now, this here is not necessarily the easiest to view, but what is going on here is essentially it has these environment CIDs, which are different Chrome extensions. And the Chrome extension that was receiving this configuration would check and make sure that all these other Chrome extensions either were or weren't installed before delivering the second stage. From there, it would actually inject different content into iframes, as well as redirect traffic to specific domains. But from URL scan, one of the things that I was able to do and pivot to other hosts is actually search for different reports that were on that same domain, or same IP address, which, as you can see, there are things like video downloaders, like FL players, which stood for Flash Player, uBlock EXT, Dark YouTube, Flash Playlist, VOC players. All of these are domains that communicate to linker Chrome extensions that pose as fake downloaders. They pose as the social media, but on the desktop version. They pose as Flash Player all the time, ad blockers. And so from here, I was able to actually find some of these Chrome extensions broadcasting their IDs, start doing analysis and researching the threat actors behind it. Here's an example of just some of the domains that are hosted on the same IP address. If this adversary had used entirely different infrastructure, switched up hosting providers, changed how their malware communicated, maybe it would have been harder to detect and they could have had it under the radar for a lot longer. But considering they had tons and tons of different extensions and other things all hosted on the same IP address, and that IP address was known to be used in past linker malware, it made it a lot easier to pivot. Now, I did mention that I also used some signatures on disk to hunt for linker malware. So what you see in the top right here is a screenshot of some of the code from one of these extensions, specifically one that communicates to flplayer.net, which this extension in particular was some sort of Flash player or something like that. Now, most of their extensions have a heartbeat functionality, as I briefly mentioned earlier. This is what that actually looks like on code. You can see it grabbing certain times, doing some conditionals, and then encoding a web request. One of the features that I found really interesting for the sake of developing a signature was the user ID down here. So all of their different extensions would develop different user IDs, but sometimes this 0 would change numbers depending on the application or other things like that. So I was able to use Yara signatures, which is a pattern matching signature library, to develop detection on this code, but allow it to be somewhat modular. So if there was a different extension that had this string, but with a different number here, it would still detect it, as well as added in detection on a bunch of the different functions that was used in their names in JavaScript. From there, I actually scanned the extensions that I had downloaded offline and was able to gain not only some more insight on linker extensions, but also find some other Chrome extensions that had functionality that were similar but weren't actually linker, and that helped me improve my signatures over time and help gain a better detection threshold as well. Okay, we're going to talk about some examples here of different Chrome extensions I found out there in the wild and how you can actually tell they're malicious, and then I'll be talking about some of the challenges and interesting insights in disclosing this and trying to make a bounty. First, video downloader. Like a lot of their extensions, they will beacon to a command and control server, look for additional configuration, and then if it receives the configuration, it will load it via a script into every single page you visit, regardless of the content on it, and then from there perform malicious activity or something like that. But if you want to actually receive that script, you would have to bypass and actually receive the second stage, which I haven't been able to replicate forcefully. Some people have reported seeing it after like a week-long installation or things like that. So it may be some sort of server-side verification. So one thing that stood out as I was reviewing these extensions is I kept seeing a bunch of extensions that had the exact same set of permissions, which is shown here. I guess for some reason they decide that's what's needed, but it does give them the ability to filter any web request in the browser. It gives them the ability to use Chrome storage to save configurations offline, and it gives them access to like interact with the tab you're on. But I think that may have actually been just the default of the video professional downloader. Anyways, it was not legitimate. These are some of the permissions it uses, but let me talk about one of a very similar Chrome extension that gained a lot more visibility and also helped me report this whole thing, Page Ruler. In March, Brian Krebs, the author of Krebs on Security, posted a blog post called The Case for Limiting Your Browser Extension. And essentially, the Chrome extension Page Ruler, which had about 400,000 downloads at the time, had impacted Brian Krebs, where he had saw adware delivery in the browser and ended up writing an article on it. At the time, I was actually in the process of disclosing that to Google through the HackerOne bug bounty platform, and had about a handful of other linker extensions reported at the same time. This, after Krebs wrote about it, Google kind of noticed my reports a lot quicker and sped up that disclosure process. But the thing that makes this extension really noticeable, more than just Krebs getting infected, is it was actually a decent extension. It essentially, you could press it and it would show you grids, and so you could measure your content. And if you were like a web designer or something like that, it would make it a little bit easier to understand and see how big things need to be or whatever, something like that. But a certain company, a threat actor behind Linker, was purchasing Chrome extensions. And a lot of times, yes, they do get shitty Chrome extensions or poorly developed Chrome extensions like fake video downloaders and Flash downloaders, but they would also occasionally buy high quality Chrome extensions like this one. Now, you may be wondering who is behind this. Previously, some reports mentioned a shell company called BR Code or Bro Code based out of Hong Kong. Security Street hinted that there appears to be ties to Eastern Europe and that region. However, I can say definitively the threat actors behind this aren't necessarily going for stealth. So that extension, Page Ruler, communicated to a domain called page-ruler.com. One of the things that I checked for when I was investigating this domain was the presence of a Git repository. So even though the website wasn't advertising that it was built on with Git or anything like that, I kind of just had to check and guess, but it did have a Git configuration file that referenced a private GitLab repository that is shown on the left side of the screen, monetizeus.com. The repo name is promosites pageruler.git. Coincidentally, after I discovered this, I went and checked, and a ton of the other extensions that I had already been analyzing also had Git configurations that referenced a private GitLab repository. So I wondered to myself, who is Monetizeus? Well, I visited their site, and they don't necessarily make it very hidden with the we're buying Chrome extensions. So I ended up doing some research on them, trying to figure out a little bit more about this threat actor and some of their intentions, when ultimately I kept following the thread and I found this forum posting on a forum called GoFuckBiz, which is it's a Russian language forum. It's been around for a good bit of time, but it's essentially used for affiliates, spam networks, things like that. And I found this post from 2015 actually 2013, excuse me. No, 2015, sorry. The user registered 2013. But this post from 2015 about the launch of Monetize Us, an affiliate program that the solution is offering to different website owners, network owners, JavaScript owners, and distributors and browser extension owners, claiming they monetize via coupons, smart links, in-text ads, pop unders and banners. Minimum volume, 5,000 users. Exploring some of this user's activity on the same forum, and I found a really interesting post about how this threat actor avoids detection from Google somewhat. You can see it here. It is translated from Russian, so some of it might not make the most grammatical sense, but one of the interesting things that I see is the amount of focus on having your own different Google developer accounts per an extension, to the point of them even buying the entire Google developer account, as well as seeing the use of virtual machines to log into the Google accounts. So I guess that Google has enough insight that they're using virtual machines and rotating IP addresses to log into developer accounts, but they don't bother changing their domains off of the same web server with the same IP address for multiple years. After Brian Krebs's article was disclosed and some of the bounty reports that I had submitted to Google went further down the pipeline, the Monetize Us company slash group, I don't really know if you can call them a company fully, shut down their affiliate program. Visiting the website to this day will display this message: thank you for your cooperation. Great, we got it done. They're no longer operating, not so fast. While exploring the subdomain information of the Monetize Us website, I discovered a second shell company of the same threat actor, Advertise Us. Rebranded, totally undercover, only has one linkage to the same server, except it doesn't. This site actually has the exact same sitemap as the old one that references the Monetize Us domain, further linking that this is literally the exact same website, template, and company, just with a slightly different name. Disclosure. So I did start this research with the intention of gaining bug bounties. At the time, I had never received any bug bounties before, so I wasn't fully expecting to make anything at all. I was kind of thinking this could be fun, exciting research. If I make any bounties in the process, then even better. So Google launched their bug bounty platform on HackerOne. Now, HackerOne is commonly used for a lot of web applications, not really for privacy abuse and threat hunting. So it was a little bit difficult to convince triagers that Chrome extensions that are going through excessive lengths to cover up their tracks and try and prevent researchers from detecting their adware was malicious. In December, I reported my first linker extension to Google. A month later, I reported 5 more. Then it wasn't until the end of January that my first report was actually forwarded on from HackerOne to Google. In February, I got the first triage status, which means that the report is actually valid and that it has likely to get bounty. In March, only 6 days after Brian Krebs published about the Chrome extensions, I received a very generous bug bounty reward from Google that helped me through some financial uncertainty between graduating and starting a full-time job. And shortly after that, in April, Google left HackerOne and is now in the process of standing up their in-house bug bounty program. A little bit of statistics on just my entire bug bounty hunting process so far. I have reported to Google over 30 different Chrome extensions from this adversary alone. The install count, over 15 million users and likely a good bit more. And here are some of the examples of the Chrome extensions that were being used by this threat actor to deliver adware and to abuse user data privacy. And as you can see, some of these things look pretty legitimate and have like a lot of users because they were legitimate extensions at one point in time before they were purchased by the monetize us or advertise us group. So just a little bit of closing thoughts I have on the results of my research and the Chrome Web Store. I have seen some of these extensions I reported show back up on the store, which is frustrating, but fortunately in late August, they're implementing a new policy which pretty much states that developers can only have one extension of the same purpose. Will this actually stop these threat actors from trying to flood the store with garbage Chrome extensions? I'm not sure, but I do think that between their implementing of new policies, willingness to actually start a bounty program and put their money where their mouth is, it's definitely a sign that they care about their Chrome store and are trying to actually improve it. I know this stream is a couple seconds delayed, but if you have any questions, feel free to drop them in the Discord. In terms of bounty hunting for more money, I haven't even touched the apps yet. And I know there's definitely a ton of like popular apps out there that are covertly selling data and hijacking sensitive information from users. And I encourage everyone to look into it if they want to, because ultimately these kind of bounty programs are going to improve our digital ecosystem as a whole. And I would be rejoiced to see if other big tech companies like Mozilla move towards models like this and expand bug bounty beyond just web applications. I'll give it a second just for any questions to come in if there are any. So the question about auto scanning for malicious phone home code, I know they do have scanning, but the thing is, a lot of these linker extensions will communicate and receive what looks like a harmless configuration from the C2 server. And then periodically, after a certain amount of time would happen, that configuration would actually change. Like that one report from URL scan was a full configuration. Normally the configurations are a lot smaller. And so unless you actually wait and put in the time to see and like bypass the server side checking, then it won't deliver that malicious code. So the stores about obfuscation, technically it's not really allowed, but just having obfuscation isn't enough to actually report it. So that's not in scope of reporting. But then you see tons of developers doing stuff like minifying and stuff, which is allowed. So it gets kind of hard to draw the line of when are they trying to obfuscate their code versus when are they just trying to make it minified. Thanks everyone for stopping by and watching. I hope that it was informative and opened the eye up to some of the world of Chrome extension security.